So here we're looking at implication. Implication is when we have a statement that has the form of if something, then something else occurs. So in the mathematical terms, we're going to have if P, then Q. And you're going to notice that the if and then is represented by the arrow, or in some textbooks and some notes and by some authors, the double arrow. So the arrow is going to be representing the if and the then in this form. Now the main idea with this is we're going to have some hypothesis, and this hypothesis means then there will be this conclusion. So hypothesis, if then, the conclusion. And another way we can say this is we have an antecedent, so something that comes before, ancestor is before, just to remind you of that, and it produces, or if you have the antecedent, you are going to get the consequent. So antecedent and consequent, or hypothesis and conclusion, are familiar terms that you would use in this situation. Now, I just want to be very, very careful here that nowhere is it saying that you have to have P to get Q. It is saying that if you have P, then you will have Q. So if the antecedent exists, the consequent will definitely exist. But nowhere is it saying the consequent can't exist without the antecedent. So let's just write that down quick. So again, nowhere is it saying that you have to have P to get Q. It is only saying if you have P, then you will have Q. Okay, so quick reminder of implication: if P, then Q; if the hypothesis, then the conclusion; if the antecedent, then the consequent. And the situation here is it's only saying that if you have the hypothesis or the antecedent, then you have the conclusion or the consequent. It is not saying that the conclusion or the consequent can only exist or is fully dependent on the hypothesis or the antecedent. So let's go through an example to explain it along with a truth table. Okay, so here we have the example of if you win, then you get no homework. So what we're going to do first is you're just going to write down the options for the antecedents and the consequence, or the hypotheses and the conclusions. So here you have you win. So what are the two options that you have? For it to be true, you do win. And then you also have the situation of you don't win, or there is no win. Okay, so you have those two options for this antecedent. Then you have then you get no homework. So you also have two options there. Either you get no homework or you get some homework. So you get no homework or you get homework. So those are the two options there for the true and false situation. So let's write those down. So our options are you win, and then you get no homework. So one option is you win, another option is you get no homework. And those are a pair that go together. The next one is you win, but in this situation you get homework. So this is a pair of facts that you can put together. Then you have you don't win, so you lose. And you get homework, or you get no homework. Let's start with you get no homework. So again, a pair of facts that you can put together from the statement. And then you have you lose, and you get homework. So all we've done here is we've taken the statement, if you win, then you get no homework, and we've broken up the antecedent into its two possibilities, and the conclusion or the consequence into its two possibilities. And then we've just set up pairs of data. So we have the you win features twice with the option of you get no homework or you get homework kind of a situation. And you have you lose set up twice with the options of you get no homework and you get homework. And now you have all the different pairs of possibilities for this statement. If you win, then you get no homework. Now what we're going to do is we're just going to look at whether these are true or false. So you win is true. It matches the statements antecedent. So you're going to put true there for both of them. And the other two are false. So we're going to put false there for those because they don't match the statements antecedents. Then we're going to go to you get no homework. That's true. It matches the consequent. You get homework as a doesn't match, and so on. So now we have true and false values for all the data pairs that represent the options in the statement. If you win, then you get no homework. And now what we're going to do is we're going to see if we are lying by saying any of these data pairs. So the only option where I would accuse you of lying if you gave me this data pair is you win, you get homework, because it's stated if you win, then you get no homework. So this is an outright lie. The bottom two are actually not mentioned in the statement above. So you can't really say anything about them because they're not outright lies because they're just not mentioned. So the only one which is a lie is the you win, you get homework. It's the only lie based on the statement you were given, the if-then statement you were given. So based on the implication given. And therefore, we are going to say that this data pair is going to be false. So if we had to write this as a implication, it's going to be false. Now let's try and connect what we have up to a truth table. So just a quick reminder that you win is your P. And you get no homework is your Q. And then when we look at the two data pairs and decide whether they are lies or not together, that's going to be your if P then Q. So where we look at it together is going to be your if P then Q. Okay, so we're just going to readjust our page quick. And now we're going to start writing our truth table columns. So we're going to have P, and then all the options for P, which is going to line up with the above. So true, true, false, false. So again, it's just lining up with the data options that we had, the pairs of data. And so we have our hypothesis or antecedent P has the options of it can be true, true, and then false, false. Because remember, we're going to have data pairs. So it's going to be connected with the Q. Then we're going to write our Q column. So our Q column is going to be true, false, true, and then false. And once we have all our data pair options, let me just finish writing false. There we go. We're going to have a column for if P then Q. Now, the important thing to note when it comes to the true and false of the if P then Q, it's just referring to which of those data pairs is going to be a blatant lie in relation to the statement. So the only one that's going to be an outright lie is going to be that second one where we said therefore false. The rest, it's not going to be a lie, so that statement is still going to be true. So we're going to put in by the second one false, and the rest are going to be true. So let's fill that in. True, true, and true. And let's just add our columns and just pretty it up so we can see that it is a table. And there we have our truth table for our implication of if P then Q, and why certain ones are true and certain ones are false, and how you need to read your formulas in regards to this. And by formula, don't forget this if P then Q is technically a formula. It is a statement as well.